Topic of the class is Multiplexer Implementation. The topic is from Combinational Circuits. Subject name is Digital Electronics. Let us see the problem and its solution. Implement the following function using 4:1 mux. The given Boolean function is comprising of 4 variables a, b, c, d, and the list of minterms are given. Okay. So, as it is clear, it is a 4 variable. 4 variable means 2 to the power 4 means 16. Okay, so it can be easily implemented using 16:1 mux, but we are supposed to use here 4:1 mux. So, first we will think of 8:1 mux and then split this 4:1 mux into 4:1 and 4:1 mux, because we have to implement the problem using 4:1 mux. So, first let us draw the implementation table of 8:1 mux and then split into 4:1 mux, 4:1 mux. So, let us start the solution. I have written the Boolean function given in the question as below. Drawing the implementation table. Implementation table, we are writing it for 8:1 mux. So, the variables inputs are D0 to D7, D0, D1, D2, D3, D4, D5, D6, D7. Here we are having 4 variables. Okay, so let us pick the first variable for the implementation table and write it as A bar A. So, here we are having list of minterms. So, for D0 to D7 we have written 16 numbers 0 to 15. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have written 0 to 15 inside this table. Now, circle the numbers which are there in this list of minterms. 0, 1, 2, 4, 6, 9, 12 and 14. The list of minterms are circled in the implementation table. So, we know how to write the output of this data line. If the above one is circled in this column, if the above one is circled, we write it as A bar. Both are circled, we take it as 1. Above one is circled, A bar. None of the numbers are circled, so it is 0. Both are circled, 1. In this column, both are not circled, so the output is 0. In this column, both are circled, so output is 1. Here both are not circled, so 0. So, what does it mean? The D0 input is to be connected to A bar, D1 is to be connected to 1, D2 is connected to be A bar, D3 is 0. So, for 4:1 mux, we will take the inputs D0 to D3. For another 4:1 mux, we will take the inputs from D4 to D7 and connect their inputs in this way. D4, D5, D6, D7 are connected to 1, 0, 1, 0. Let us see the implementation using 4:1 mux. So, here we are having 4 variables. The first variable we have used in the implementation table, and C and D 4:1 mux. 4:1 mux we are going to implement. 4 means 2:2, means 2 select lines, 2 selection lines or select lines. So, they are S0 and S1. So, S0 and S1 are connected to C and D. In this, the last 2 variables are taken as selection lines, because we need 2 select lines for 4:1 mux. So, this is how we have done. There are 2 4:1 mux. The inputs for first mux are D0, D1, D2, D3. For second 4:1 mux, the input is D4, D5, D6, D7. We have taken 2 4:1 mux and each is generating one output. Okay, and we are implementing a multiplexer, so it will have 2 to the power n inputs and 1 output. So, the output of both the muxes are odd, and to get the function f. Okay. Now, 4:1 means 2 select lines will have. They are S0 and S1. This mux is having select lines S0 and S1. So, S0 is connected to C and S1 is connected to S0 is connected to C, S1 is connected to D. Now, to enable the multiplexer, we need an enable input. So, that is connected through variable B. We are having 4 variables A, B, C, D. So, A is used in the implementation table and B is used for the enable pin. So, the first mux will be enabled when the output is low. So, the output of NOT gate of B is given as enabled to the first mux, and direct B input is given to the second mux. Okay. So, B is used for enabling, C and D are used for selection lines. Now, let us see D0 here. D0 is connected to A bar, D1 is connected to 1, D2 is connected to A bar, D3 is connected to 0, D4 is connected to 1, D5 is connected to 0, D6 is connected to 1, D7 is connected to 0. So, now see here, D1 we have connected through a blue line. So, here we can see 1, D6, D4, D1, D1, D4, D1, D4 and D6. D1, D4, D6 are connected to 1. Okay. Next D3, D5 and D7. D3, D5 and D7 are connected to 0. Okay. So, we have connected the inputs to 1 and 0. Now, D0 and D2 are connected to A bar. So, I have taken the input A bar means D0 and D2. These two are connected to A bar. Okay. So, this is how we implement the multiplexer for using 4:1 mux for the given Boolean function. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.